finally, I'd like to introduce Dr. Jack Ahern, who will be joining us today to tell us about sustainable cities. So,
I'm a professor of landscape architecture, and so I'm talking about sustainability from the perspective of the design professions and planning, urban planners who think about cities and who think about how to make cities more sustainable, and landscape architects who design cities to be more sustainable. And sustainability said, no. Sustainability is about looking at the environment through the human perspective. It's about meeting the needs of present generations without compromising the ability of future generations, right? And that's about people. So it's looking at all these issues through human needs. As a landscape architect and urban planner, we focus a lot on patterns. We look at how cities are configured, urban pattern and sustainability. Here is one way that patterns can be described by looking systematically at the structure of cities: form, density, heterogeneity, and connectivity. Imagine you're flying over the city in an airplane and you try to describe what you see. A lot of buildings, a lot of roads. Okay, we can have some very quick kind of intuitive kind of gut responses. But then if you become a bit more familiar with that and you try to describe the urban patterns in a more rigorous, systematic way so that people from other cultures or other disciplines can understand what you're talking about, then you need some consistent terminology and language. So here it is. Okay, heterogeneity refers to diversity, all the different things that comprise a city. Open spaces, parks, residential, commercial, industrial, institutional, transportation, and how are all of those different land uses and land use types configured on the landscape. And finally is connectivity, which is an important property of landscapes and cities. Connectivity is a physical property that supports particular functions. For example, driving, right? You can't go anywhere if the roads aren't connected. So connectivity is so universal in our road system, we don't even think about it, right? You don't think about, I need to go to Greenfield. Does the road go there? Of course it goes there. We know that, we assume that. When we think about connectivity in other respects, it's not the same. Hydrology, for example. The stream networks that originally came from the tops of the hills down to the valleys and to the oceans were always completely connected by definition, right? But then we intervene with urban development and we put the streams into concrete pipes. And that, in many respects, breaks the connectivity of the streams, especially in terms of aquatic life and water quality. If we think about connectivity of habitats for wildlife movement, if a species of wildlife wants to go from Amherst to Holyoke and stay in the forest, that's going to be a problem because the connectivity of the forest has been fragmented by roads and urban development. So connectivity is an important systemic property of landscapes and urban environments that is really important for particular processes: transportation, communication, movement of water, movement of wildlife, movement of nutrients, etc. And it's a useful way to describe the physical pattern. Are you familiar with the concept of ecosystem services? Ecosystem services are the services and functions that ecosystems provide that benefit human society. And these are some examples of them, but I'll get to that in a moment. So the ecosystem services are important because they do things for us, right? It's the anthrocentric perspective on this. Flood protection. When you keep floodplains open, free from development, floodplains can provide flood protection. They're delivering a service to people. Ecological economists argue that floodplains are therefore providing a benefit that should be valued. And when you value that, then you have an argument to counter ideas to develop floodplains, because when you fill in the floodplains or build walls right next to the river, you're causing more flooding downstream, and that causes expense and damage to other folks. Other examples of ecosystem services are illustrated here, and I put them into this model that I can remember, ABC, abiotic, biotic, and cultural. Abiotic to non-living, biotic to living, and cultural to human or social dimensions. It's just a way of classifying it. There's nothing particularly significant beyond that. So it's a way of classifying these things into columns. So these are examples of ecosystem services that sustainable environments or sustainable cities can provide. So these are all examples of services that the environment can provide that are beneficial to humans. So it gives a bit of a more explicit argument for why should the city be sustainable. People will say, come on, we don't have time for that. We don't need for that. Show me the money, or prove it to me. How is this going to benefit me, or how is this going to be a benefit to our community? This is how it benefits, right? Good environments provide all these services, and when these things are done skillfully and creatively, you can design and plan urban environments that provide ecosystem services in all the categories. So urban sustainability, here's a focus on a process of hydrology. Urban environments change hydrology because in a non-urbanized environment, when it rains, the rainwater falls on forest, for example. The leaves catch the water slowly moves down the trees, it hits the ground is covered with leaves. If the ground gets very wet, like it is now, the water soaks into the ground, eventually it goes into the streams. That's the natural process. The urban process, the rainwater falls on the roof of the building, it rushes across the building, it goes down a pipe, it goes into another pipe, and within minutes it's in the stream. The stream goes from being a normal stream to a raging torrent in a matter of minutes, and then as soon as the storm is over, the stream goes dry, and there's no more water in it because there's no water in the ground. So the urban environment has a lot of impact on hydrology as a process. So what do we do to try to manage that? We do things like this on the upper right. Instead of having a concrete lined channel, if that channel can be made pervious on the bottom, we can collect that water and then still get some of it into the ground. It's a kind of a hybrid solution. To think about ecological engineering or dealing with the stormwater in a more creative way. Not trying to restore a natural stream in the middle of the city, but what's appropriate in the city, what can be done to improve the hydrological performance. So, this is what I want to finish with. A few big ideas: sustainability, resilience, and urbanism. Hopefully those themes came through. How are we doing with this? Do we have good models? How will we know if the cities that we plan and build are sustainable or resilient? And what do we need to know in order to do it right? So I hope that some of you might be interested in this kind of perspective. If you are, we're over in Hills, right down the street. We have a big undergraduate program in landscape architecture where we learn to do all of these things. So, thank you. I'm happy to take any questions.